Welcome back. We are still talking about section 7.8, where we're talking about compound interest. And specifically, we're talking about when interest is compounded continuously. And so let's look at this next problem. Maria is saving for a new car. How much money does Maria need to deposit now in order to reach $40,000 in 7 years? Her account has an annual percentage rate of 4.1% with interest compounded continuously. How much money should Maria deposit now? So we will be using the formula A of t equals p times e to the rt power because it says it's being compounded continuously. So let's go ahead and put those amounts in and see what we come up with. We notice that we want to know how much money Maria needs to deposit now. So we're not solving for that A of t this time. We're solving for p. Now we could have solved for p in this formula if we're going to be finding a lot of these same kind of problems, but we don't have to. So I'm going to solve this one the other way, where we put those amounts in, and now we're going to solve for p. So p is connected to e to the 0.041 times 7 power by multiplication. So that means we need to divide both sides by that e to the 0.41 times 7 power, and then we'll have what p is. Then we can see that these will divide out. We're left with p on this side. And so now let's figure out what 0.041 times 7 is. So we'll have 40,000 divided by e to the, when we multiply those together, we get 0.287 as our power. And that will tell us what p is. So go ahead and pause the video, put that in your calculator, see what you come up with. Well, when I round to the nearest cent, I came up with $30,020.47. So that's the amount of principal, or how much I would have to deposit now in order to reach $40,000 in 7 years. That's a lot of money to come up with now. So maybe you might rethink what you want to do there.